But now, I want to hear the stories of the last 2 days from our paddlers, led by Eric Compas of the University of Wisconsin-Whitewater. So, Eric, you want to share with us what you've learned from our one little, as Mark said, this one little stop doesn't tell us the whole story, but it's interesting.
Well, hello everybody. My name is Eric Compas. I'm a geographer, and I like to think that wasn't fate, but I've been mapping things since I was a kid, caves and my bike routes and everything else. I probably should have gotten therapy at some point, but that didn't happen. But I hear people like Jim talk about how wonderful maps are, so maybe I didn't need that therapy. I want to tell you a little bit about the device itself and some of the technology and why we decided to do this, and then we'll look a little bit at how the map works and some of the data we've been collecting the last couple of days. With liking maps, I always want to see things spatially. And so that was one of the origins of the project, was trying to figure out how could I take water quality data that I was looking at and being part of as a water quality monitor. I've been on the Rock River Coalition board for the last 2 years, and Nancy had a picture of people out in the streams taking a sample. And like we would spend several hours, and after several hours we'd have like one dissolved oxygen measurement. And then that would go off into a database, and eventually we'd get that information back. Through Nancy's work, through the work of DNR, I could find a map and see a couple of those data points, but it was hard for me to see like what were the trends through time. How did my data point compare to the data that was collected nearby me? And I thought, there's new technology, there's new ways of doing this. Let's explore that and see if this is a useful way of understanding water quality within the basin and potentially even more broadly. I had a chance meeting with another professor at Whitewater, a physics professor, that was messing with these little microcontrollers. And I've always been a hacker and a tinker, and I love making things, so this was like a new toy. So with a class project, we made something that measured CO2. We went around to classrooms and measured CO2 levels. Like you hear about CO2 for climate change, the CO2 actually, you can have too much CO2 in the atmosphere and it impacts your ability to think. And we were in this little device, we were going around measuring in lecture halls and finding CO2 levels that were almost in violation of OSHA standards. And there was a study in Berkeley that was showing that students perform poorly at CO2 levels at higher levels that we were actually measuring. And so I was like, well, this little device is allowing me to see the world in a new way. We can connect it to the web pretty easily and make graphs of this information. And so I thought, well, wait a minute, with the water quality stuff, is there a possibility to do that there? So a couple years ago, a year ago, I made a prototype with just temperature, showed it to Suzanne and Nancy, and they thought that looked intriguing. Hey, what else could you do with this? Last summer we made a full device. I had a couple students going around paddling around Jefferson County, and then this is the full test that we've been looking at. So how this works? Has anyone heard of the Internet of Things? This new idea that like everything in your life is going to be connected to the internet. Like you're gonna like I'll be able to get on the internet and tell if you toasted your bagel in the morning. Like your toaster's gonna be connected, your refrigerator's gonna be connected. In some ways it's ridiculous, but there's a lot of things in which that can change our lives by having more information about the things around us. So that's kind of the model that I've been after with the device. So this is the box of all the little gadgets. So there's a microcontroller in here with a little battery pack. 3 little tiny microcontrollers that are connected to the arrays that we have, the probes that we have. We have dissolved oxygen, pH, electrical conductivity, and temperature. And you've heard Mark and Nancy talk about some of the other things that are being measured, like phosphorus and so forth, that are really important. We started out with things that we could afford. We're less than $1,000 worth of equipment here. And to measure phosphorus and some of the total suspended solids, the instruments and the technology in some cases doesn't exist, and it's very expensive. So we started with something that was doable. That talks to a cell phone. So all of us have the technology probably in our pockets right now to do kind of Internet of Things, to connect these devices, to become mappers. Probably a lot of us are wearing Fitbits or other devices that are along the same spirit. This takes a reading from this and then sends it up to the web, and it goes on our servers. Now here I want to acknowledge two of my students, Porter and Tyler, have been back in the labs. While Jeff and I, the paddlers, get to be out on the water, they're back in the lab making sure that everything's working. And every now and then getting the picture of like, well, that looks nice, while they're watching the servers. So we developed a website to be able to watch this. This is kind of an overview, shows the latest dots where we're at, and some pictures, our Facebook feeds, that's earlier today, the events that we're doing across the whole event, and then the live dashboard that gives us the latest reading that was taken, let's see, at 1:07 p.m. Our dissolved oxygen of 12.8 milligrams per liter, temperature, conductivity, and pH. And then here's where, to me, this is where the payoff is being able to look at the map. Unfortunately, we don't get to look at this while we're in the water. We just look at this device and we hear a beep every now and then. So someone's asking, well, how's the water quality? I'm like, I have no idea. I gotta wait till I get back and look at the map. And then we can pan around. We can click on individual dots. That looks like a solid blue line, but it's actually individual measurements. If I get in, I can see the individual dots. We're taking a measurement every 10 seconds. So instead of having 2 or 3 hours to get one measurement in our typical sampling procedure, we're getting a lot more detail here. It gives us some sense of the trends through time. We actually had 2 different samples there that are overlapping, so I'll go a little bit further up the stream. We're also, again, to help tell the story, taking pictures along the way, and this is one of the things that Porter and Tyler are doing. They're taking the photos that we're taking during the day and adding these little dots, these little media dots. So let's see, we're up in the main ditch here. Now we got Jeff and my data points from today, so we're at about 11:43. And our graph's not cooperating here. The numbers aren't quite showing up. So it looks like about 13. So a small trend as we go downstream, a little bit lower, but those are almost within the margin of error of our units. So dissolved oxygen fairly high. And so far, when we look across the data that we've collected the last few days, everything's kind of what we've expected. It's been no indications of unhealthy stream conditions. Dissolved oxygen is fairly high. pH is a little bit on the basic side. Given the types of rocks and substrates that we're going through, that's kind of what we expect. Conductivity levels, which measures how much how easily electricity will move through the water. The more that's dissolved in the water, the more easily it conducts electricity. So we've got a lot of dissolved material in the water, and most of that's going to be stuff that's picking up, again, off the substrate, probably some magnesium and calcium, some of the phosphorus, but that would be just a minor component of those dissolved materials. And then temperature levels. And a few of the things to using the map, I'm talking about all these different metrics. The default one is dissolved oxygen. I can switch between different metrics, looking at temperature changes. I can see what we did last weekend in our prototype run. It's a little bit warmer than the water is right now. Conductivity levels. What we're looking for that would give us some indication of some pollutant is if we pass by a side stream or an industrial facility, we saw a significant uptake in the conductivity. It would give us an indication that something's been added to the water that may warrant further investigation. And then pH. pH has been very, very consistent. The numbers on our graph here, again, are almost within our margin of error, so slightly basic water. All right, well, that's, again, so my hope as we go across the whole 11 days that we get a different picture of the Rock River than we had before. We have a new map that we didn't have before. And that, again, will be a baseline. I'd love to repeat this. Suzanne, if this wasn't much work, we can do this every year.
Sure. We have that question.
And to see how things change through time. Or to look seasonally, to come back in late summer, like Mark was talking about some of that, the seasonal changes in our water, that there's certain times of the year that things are particularly stressful. So maybe our dissolved oxygen levels don't look so rosy if we come back in late August or early September. So, we've got a new map, interested to see where it leads us and finding out what's happening in the river and communicating with the public. Thank you. Any questions from you guys?
Any questions?
Can I do-
Yes, of course, Nancy.
No, what I think is so great is that, I didn't mention it in my talk, but the stream monitoring program that I oversee, the volunteers that I work with are on wadable streams. And so this effort provides a way for volunteers to get in, the crawfish and the Rock River, where volunteers, our methods don't allow volunteers to go because it's just too deep. So, this is a wonderful way to augment what volunteers can do through that.
You said 2,900 miles of streams?
Yes.
So at 10 miles a day, we're only looking at 290 days to
A
cover
year.
the whole basin.
Just a year.
All right, thank you,
I'll pick
guys.
the summer months.